Good morning, everyone, and thank you for joining us for this month's TRFA webinar. We have developed this program to help deliver education to TRFA members. The audio for today's event will be broadcast through your computer speakers. Please be sure they're turned on and the volume is turned up. All participants have been placed on mute. This will help us to better hear and understand the presentation. If at any time you would like to ask a question, please use the question feature or the raise your hand feature located on your screen. Only the presenter and I will see your questions. At the end of the presentation, I'll read any questions that were not answered during the webinar. At that time, you'll be able to enter more questions into the chat feature. All participants will remain on mute. Lastly, I want to let you know that this webinar will be recorded and shared on the TRFA website for member access in the future. Today's webinar is a review of renewable polyols, diols, and isocyanate blocking agents for polyurethane formulations. Please welcome Hyun-Mi Kim with Cardolite Corporation to give the presentation.
Thank you, Rick. Hello, everyone. My name is Hyun-Mi Kim. I work for Cardolite Corporation. So today I'll cover renewable polyols and diols, isocyanate blocking agent for polyurethane application. So, first part of talk will cover renewable polyols and diols manual and their key application, adhesive and coatings. I'm going to touch on the plastic bondings and coatings application. And second part of talk will cover isocyanate blocking agents, especially focusing on the deblocking performance of this new isocyanate blocking agent. In case you're not familiar with cashew nut shell liquid technology, since I'm going to cover and then mention cashew nut shell technology throughout the presentation, I would like to briefly touch on the what cashew nut shell liquid is and where they come from. So as you can see, this is the cashew fruit, and cashew nut shell liquid in fact come from this. When you look at the cross section of this nut, come from the shell. This is a honeycomb structure, and this liquid is come from the shell. That means this product is non-food chain product. And as you may know, this cashew tree grows in the close area that close to the equators, and they therefore they are available annually, and then they harvest annually as well. And the key countries that manufacturers of this product is in Brazil, India, and Vietnam. Also, Southeast Asia regions and some Africa. Even though Cardolite focusing on developing product based on the cashew nut shell liquid technology. However, we have explored and developed the other renewable polyols and diols based on other renewable resources, something like vegetable oil feedstock as well. So I will briefly mention some products that use non-cashew nut shell liquid technology. So I'll start with talking about manol. This manol, as you can see, it is the alkoxylated cardanol. So this structure that I'm pointing, this is the cardanol, and then you can simply add the ethylene oxide group. As you can see, you can control the adjust the number of ethylene oxide group based on your need. So what we have developed is, the product with the 1, 7, 9, and 12 ethylene oxide. And as you can imagine, having more ethylene oxide group will give you hydrophilic performances, especially when you look at the cardanol structure. Cardanol is hydrophobic molecule with the 15 carbon. So therefore, adding different number of ethylene oxide will help you to balance its hydrophobicity and hydrophilicity nature. And as you can see, as we increase the number of ethylene oxide, you can see the HLB, which is hydrophilicity, lipophilicity balance number, increases, and also viscosity also goes up. So basically, carbonyl phenoxy OH is prepared, and it is a suitable alternative to standard alkoxylate nonylphenol-based surfactant and diluents. Their performance are comparable, and as you can see, structure-wise is also quite similar to nonylphenol. And not only ethylene alkoxylate carbonyl, but also carbonyl itself can provide a surfactant effect because the structure itself has hydrophobic structure with the hydrophilic component in it. So this carbonyl can be also used as a surfactant and diluents in selected polyurethane application. So these are the Cardiolite product that typically recommended for coatings, adhesive, and sealant and elastomer application for polyurethane. From here, we have a 9001 family, 3-year product. These ones are the one has a lot of cashew nut shell liquid structure, and therefore these products are very good on the lowering moisture sensitivity. Also offers excellent alkaline resistance. And now, earlier I mentioned that the Cardiolite also developed product that utilizing non-cashew nut shell liquid feedstock. Those products are NX9005, NX9011, and 9014. These three are non-CNSL polyols, and especially 9005, 7 and offers elastomeric performance and low TG, and 9014 offers excellent color stability. 9008 offers high strength and high TG. So I'm gonna go over those one again in the next slide. So this slide basically, these polyols are simply cured with the polymeric MDI at the isocyanate index 100, so theoretical mixture. And we cure them at room temperature for 7 days and collected tensile, show D, lab shear, TG, and elongation. From this study, what we learned is that elastomeric performance can be achieved by NX9005 and NX9007. And now if you're looking for high TG, high strength like epoxy, NX9008, it can offer those performances. And if you're looking for excellent bond strength on metals, including aluminum, NX9008 and NX9014 can provide those performances. We also measured cure speed of each polyols, curing with the polymeric MDI in this case. So measure dry hard time at different temperature. Some temperature as low as 5 degrees C and 0 degrees C. In this study, we identified that Light 9001 as the product that offers the fastest cure speed in this study. However, as you know, those pot life and cure speed can be easily adjusted by adding your choice of catalyst, metal catalyst or tertiary amine type of catalyst. Also, you can also control those cure speed by adjusting the pH. Typically, high pH like alkaline condition offers faster cure, and then acidic condition slow down the cure. And then you can also use non-reactive diluents to adjust the cure speed as well. So in this study, you can see the color stability by exposing your panels to QUV chamber. So we formulate the polyols curing with the HDI trimer, which is typically used for the light, good color stability coatings. In this study, NX 9014 have shown excellent color stability after 28 days of exposure, still maintain the delta E around 1 and below, and then followed by 9005, 11, and then 7. 9001 has show reduced color stability after 1 day, delta E jumped greater than 3. This study is to explain moisture sensitivity nature of this, in general, polyurethane technology. So one of the ingredients that can react with the moisture is the isocyanate. As you know, isocyanate, when isocyanate sees the moisture water, it can turn to ultimately amine functional group, amine functional, and then at the same time emits the CO2 gas. And as you can imagine, CO2 gas can create the defect on your coatings and adhesive. Ultimately, your durability of your polyurethane system will be impacted. So from this study, higher amount of CO2 means your system has a greater moisture sensitivity. So one of the way to reduce the moisture sensitivity is to choose the polyol that can offer better hydrophobicity. So in this study, we simply mixed polymeric MDI with the polyol and then a lot of water. So this is more exaggerated study. And from there, we collect the CO2 amount. And NX 9001, as you can see, has least amount of CO2, meaning NX 9001 offers best hydrophobicity. Therefore, you can lower the moisture sensitivity of your system, and followed by 9005 and 7, and then 9011. When it comes to moisture resistance, you know, we just talked about the moisture sensitivity study, but you can also, and then you care about the hydrolytic stability as well, because you know, many polyurethane link can be experience hydrolysis, meaning the bond breaks, and then therefore your ultimate mechanical performance is something like adhesion strength and tensile, or the hardness could be reduced. So in this study, we studied polyols by measuring lab shear strength change for the hydrolytic stability. So we collected the lab shear before exposure to water, and then collected another lab shear after exposing to 80 degrees C, 7 days immersion. From here, what you're looking at is, of course, you look at the product that has the least amount of lab shear reduction. So from here, what we learned is the product that has shown the best hydrophobicity in general, even from the moisture sensitivity study, also showing the least reduction on the lab shear strength. So 9001, 9005, and 7, 11 has shown the best hydrolytic stability in comparison to 9014 and 9008. We also have studied the chemical resistance of key polyols. So in this case, NX 9001 family in comparison to cast oil-based polyols. So prepared panel was exposed to acids, sulfuric acid, alkaline, sodium hydroxide, and salt for 30 days. Both products have shown the excellent performances in acid and salt, but the cast oil-based polyol have shown the blister formation only after 6 days immersion, whereas CNSF Poly 9001 family did not show any defect. So it's showing the best alkaline resistance. And as you know, the especially coatings, the product that can be, the product with the excellent alkaline resistant product can be used in a concrete type of substrate, because as you know, the concrete tend to have a high pH on the surface. Therefore, I think NX9000 polyo-based product can be excellent candidate for the concrete adhesive and coatings. Polyurethane adhesive and coatings been used for protecting and adhering plastics for quite a long time. A main reason is that, unlike epoxy, polyurethane is quite flexible and soft like a plastic in general, so it can provide excellent adhesion and performances. So what we have done here, we selected key plastics like ABS, nylon, PC, PVC, acrylic, and PE and PP. We also include a composite, carbon fiber reinforced epoxy prepreg composite to test the adhesion performances of selected polyols. From here, the key failure mode has been cohesive and adhesive combined, those type of failure. However, if when the adhesion strength is exceeding the strength of the plastics, we have also seen the substrate failure as well, because the resin itself, the pure resin itself, was stronger than the plastic. So overall, NX9005 have shown the good bond strength on nylon and PC and PVC. NX9008 have shown the best strength on a composite substrate and ABS. However, on the polyolefin like polyethylene and polypropylene, we have seen the low adhesion strength due to the low surface energy of those type of plastics. When it comes to potting, we know that the epoxy and polyurethanes are used, and however, if you are dealing with the epoxy system, we have experienced also the some limitation from epoxy. Epoxy tends to be quite brittle, therefore will impact the thermal shock resistance, and also tend to have a higher exotherm. So in this study, what we have done is we use the polyo or monool like 2020 as a plasticizer to improve the thermal shock resistance and also exotherm temperature. So as you can see, when we use the 20% of light 2020 and light 9001 in the typical epoxy system, what we have seen is significant improvement in thermal shock cycle. So this thermal shock cycle was 120 degrees C for 2 hours, and then go to negative 20 degrees C 2 hours, and repeat those tests till you see the failure. So you can see this much better performance. At the same time, we also achieved the good adhesion strength, live shear strength, and with the reduced exotherm, and then of course the longer gel time. So light 2020 and light 9001, even other polyo can be used in epoxy system to improve thermal shock resistance and also bond strength and reduce the exotherm. And I highly recommend the polyo as a very effective plasticizer in 2-component epoxy formulation. NX9005 and NX9011 can be formulated to make a 2-component clear PU formulation for flooring application. So to share that utility, we made a very simple formulation here. So use the deformer, moisture scavenger, and leveling agents, and cured with the polymeric MDI. And as you can see, low viscosity can be achieved, and also with the appropriate gel time and pipeline. So from this study, what we have seen is 9005 and 11 can offer your fast cure. As you can see, show the hardness development and day 1 and day 7. It's pretty fast. And then also can achieve excellent flexibility and impact resistance. So your Mandro Band study, it passed, and then impact resistance with the 200. And also you can have excellent adhesion on the, in this case, we studied a metal substrate. And when we measure this system and the compression strength, since it is a flooring application, and especially in 9005, we observed the elastomeric performances when we were trying to measure the yield point, compression yield point. There's no detectable point, typically indicate that system being very elastomeric. So, you know, what we have, based on what we have went through, you know, CNSL-based products typically shows excellent water resistance and offer you the lower moisture sensitivity with the excellent alkaline resistance, whereas some product that we have without CNSL tend to show the color stable systems, and also can offer elastomeric PE with the high strength, and then those product high strength for coatings and adhesive. And key application of this product has been, as I mentioned it earlier, coatings and adhesives. And you can also use this one for puddings and composites. Some of polyols are also suitable for foam applications. So next part, you know, I'm going to talk about the diodes. So we have several products of diodes, and we have NX9201, 9203, 9207, 9208. And as you can see, based on the product, it has various range of viscosity. 9207 and 08, those are waxy solid. Also with the different range of hydroxyl value. As you know, diodes are in general used in many different applications, which I'll touch on the next slide. But typically, most of diodes are designed and then meant to use to make a prepolymer. And for that, you know, NX9207, 9208 are more suitable for prepolymer synthesis, followed by 9201 LP and 9203 LP. However, 9201 and NX9203, we typically recommend this one to be used as a binder or the component in the two-component polyurethane adhesive and coatings. So just to go over the typical use of diodes, as I mentioned, diodes are used in the one-component, two-component polyurethane adhesive and sealant. Also, diodes are used to make the thermoplastic polyurethane called TPU, and using the polyurethane dispersion synthesis and formulation. And a lot of these are also using making reactive hot melt polyurethane system. And for example, TPU and reactive hot melt are typically use a prepolymer synthesis. That's why diodes are typically used in the application. And of course, diodes are can be used as a binder or co-reactant in the 2K and 1K polyurethane system. At the same time, diodes, when it comes to foam application, diodes are typically used in the flexible foams. as a formulator, as you know, you never use a one type of polyols or diols in your system. Therefore, achieving the good compatibility with the various of ingredient is quite important. So in this case, we have studied the compatibility with known other diols like PPG-based, poly-BD, and other additives, ethylene vinyl acetate, or hydrocarbons. From this study, NX9203 has shown the best compatibility, 100% compatible with the polyether polyols and poly-BD and EVA and tackifier. Whereas, as you know, poly-BD in general has excellent compatibility with many other ingredients, but it has shown the limited compatibility with the polyether in this case here. So, however, most of the CNS Carolite offered diols has shown excellent compatibility with the polyether polyol, especially 9203 being also compatible with the poly-BD 100%. Earlier, we have shown this mini study with the polyols, and we also did the same kind of study with the diols. So as you can imagine, polyether diol is a very hygroscopic and loves the water. Therefore, you can see the CO2 evolution numbers are very high. So very moisture sensitive. Now, as you can expect, poly-BD has shown the best, least moisture sensitivity, followed by 9201 and 9203, and also the other grades. So, this one basically also proved that product diols that has a greatest hydrophobicity tends to have a least moisture sensitivity. This slide is to go over typical way to make a pre-polymer, especially in this case, for our study purpose, we prepared various different type of pre-polymers using different diols. So now, if you're not familiar with the pre-polymer synthesis, basically for pre-polymer synthesis involves with the isocyanate, difunctional isocyanate, and the diols. And as you can see in here, this one shares the basic equation that you can use to calculate the amount of isocyanate and diol in your system to achieve the specific isocyanate percent of the prepolymers. So in this case, when you're ready to react, basically isocyanate will be in the reactor part, and then you slowly introduce the diols to prepare the prepolymers. For our study, most of isocyanate requires very mild conditions, temperature around 65 and 70 degrees C with the few hours with the nitrogen purge. However, if you're dealing with the TDI, isocyanate that has low reactivity, you can use higher temperature to achieve the proper synthesis. And your conversion can be monitored using isocyanate titration, and to accelerate the reaction and things like that, you can choose the proper catalyst. In our study, we did not use any catalyst to carry out the reaction, but if you want, you can use a tin or bismuth type of catalyst to accelerate your reaction. So in this slide, as you can see, we have prepared 7% isocyanate pre-polymer using various diols, PPG, PT-MEG, and polycarbonate diols, poly-BD, and the Carolite products. And these prepared prepolymers were cured with the 1,4-BDO as an extender, and we use the catalyst and then air release to prepare proper specimen, like tensile specimen. So when we look at the tensile strength, elongation, modulus, and hardness data, what you have you can see is NX9207 has the best tensile strength with elongation, quite comparable to polycarbonate diol performances. Now 9208 have shown the similar performance like a polyether diols, PPG and PTMag, and 9201, 9203 have shown similar performance, at least for this tensile and hardness data, similar performances to the poly-BD. The prepared cured prepolymers that I talked about in the previous slide also has exposed to aqueous solution like water, sodium hydroxide, sulfuric acid for 21 days. And then we have measured the change in the hardness. From here, basically, we're trying to understand the hydrolytic stability of those cured prepolymers. As you can see, NX9208 showed the least change in hardness, meaning best hydrolytic stability, followed by 9203, and then 9207. And as you know, poly-BD typically show good performance in this regard as well. But as you can see, 9208 was the best. Knowing the NX9203 or LP version having the best excellent compatibility with the poly-BD, and from our other basic study, we understood there has been synergy effect when we mix with the poly-BD and with the 9203. So we decided to make a simple formulation to understand if we can share the synergistic effect when you mix poly-BD with the NX9203 in the formulation. So in here, there's a three formulation. Formulation 1 only use 100% of poly-BD, and formulation 2 use 100% of NX9203 LP. And the formulation 3, we mix the 50 poly-BD with the 9203 at 50-50. And then these ones are cured with the modified MDI at isocyanate index of 1.05. So from that formulation, we have collected the tensile performance data, hardness, TG, water resistance, and adhesion. As you can see, formulation 3 that has a 50% of poly-BD and 50% of 9203 LP has shown the increased tensile strength and better elongation in comparison to other formulation. Also achieved very low TG, almost pretty much the same as poly-BD itself. And now, as you can see, the water absorption data at 7 days and 14 days immersion, it has much better performance in water resistance, even better than poly-BD. And we also have shown the excellent adhesion strength on the aluminum substrate here. However, when we tested in plastics, PC, PVC, and nylon, poly-BD system still showed better adhesion performance than blend. So we have looked at the key performance of Carolite diols. In summary, as a recap, Carolite diols offer outstanding hydrophobicity and excellent chemical resistance in an acid and alkaline. And we also have seen the outstanding hydrolytic stability. And one of the product, NX9203 grade, has excellent compatibility with the various polyols and additive. And some of product offers also very good and high mechanical properties in the pre-polymer cure systems. And, you know, for example, NX9207 and always an excellent candidate for making pre-polymer. In general, diols can be used in adhesive and sealants and coatings, of course, as a binder for polymer synthesis and flexible foam. But one of the key aspects of our product is to also use as an alternative for polybutadiene diol applications. So second part of talk will cover isocyanate blocking technology, especially with NX 2026, which is Cardano. And we'll go over the blocking performances and some of applications that we studied. So if you're not familiar with isocyanate blocking agents, so the way it works, as you can see in this upper part, this is basically pre-polymer. We talked about it in a previous slide with isocyanate functionalized. And when, as you know, isocyanates are moisture sensitive. Therefore, if you leave this one in open air or in some container, there's high chance that isocyanate can react with the moisture. Or if you intend to mix this one with other ingredients, then, especially with the reactor with isocyanate, you cannot stop them. The one way to control those reactivity and the moisture sensitivity is to temporarily block the isocyanates. So basically, as you can see in the structure, you put blocking agent to temporarily block the isocyanate. So this is how it look like, and then this won't be reactive to any moisture or any other reactive ingredient like polyols and diols, amines and things of that nature, as long as isocyanates are blocked. So commercially available and known blocking agents are phenols and alcohols, oxium, lactam, pyrozoles. These ones are well known. However, as you can imagine, even though this one works well in a certain application, there has been the need, especially some of blocking agent has a very high deblocking temperature, therefore limit their application. So there's a need in the lowering deblocking temperature, even making system deblock faster as well. And also toxicity issue can be improved, especially phenol family has those concerns raised. And oxium as well, MECO, it is highly volatile and has a high toxicity indication as well. And at the same time, when you have this type of block system, of course, you want to maintain the excellent storage stability. And when these ones are used, you would like to achieve the no negative impact on the performance after deblocking. And of course, you want a cost-effective product as well. Just to quickly go over the application of the blocked isocyanates in coatings, coil coatings, wire coatings, powder coatings, paper coating, electric deposition, automotive coatings, textile treatment, waterborne coatings has utilized this technology for a long time. And for adhesive, hot melt adhesive, for fabric lamination and industrial adhesives, pressure sensitive adhesive, wood and paper adhesive, and the one component, two component epoxy polyurethane hybrid adhesive, and the one component PU adhesives. These ones are the area that has utilized the blocked isocyanate chemistry. So just to now introduce the new kind of isocyanate blocking agent we call NX 2026. So simple, NX 2026 is Cardano. As you can see, this is a structure of Cardano, but NX 2026 is the very high purity grade of Cardanols with the narrow range of OH value, typical value being 187. And having narrow range of OH is important because when you do this type of reaction, try to block the isocyanate, then you have to know the OH value precisely so that you can make a very refined product. And NX 2026 is also a product that has a low volatility, and also since this product being 100% bio-based, it offers better labeling than typically known petrol-based phenols and nonylphenol. And the next slide I'm going to go over, but NX 2026 has shown the favorable deblocking performances with a low viscosity. So this slide share the performance of NX 2026 in comparison to phenol, nonylphenol, MEKO, caprolactam with the various isocyanate. So we basically blocked monomeric isocyanate with this blocking agent, and those block system tend to have increased viscosity, especially phenols and nonylphenol. Those guys tend to turn solid, whereas NX 2026 block, especially when you look at the TDI, has shown very low viscosity, viscous liquid, in comparison to, let's say, phenol being solid, nonylphenol being very thick viscous liquid, and then MEKO and the caprolactam. When you look at the deblocking temperature comparison, NX 2026 has shown lower or comparable deblocking temperature when you compare to phenols and nonylphenol and caprolactam. And in this study, throughout the study, deblocking temperature determined by using the DSC analysis method. And of course, there is a various of other methods available. You could use FTIR or measuring actual performance to determine the deblocking temperature, and etc. So here, one thing to mention, MEKO, which is Axiom, these show much lower deblocking temperature. However, as I mentioned earlier, MEKO has high toxicity concern, and also it is very volatile component. So although we talk about there's a need to control the deblocking temperature, mainly lowering deblocking temperature, and then deblocking to happen faster as well. So there's a key factors that control those kinetics. Chemical structure of the blocking agent and isocyanates is one of the contributor. Also, the polarity of solvents is contributor, and type and the concentration of catalyst, especially like metal catalyst or amine-based catalyst, will be a main contributor, which I'm going to talk about in the next slide, later slide. And the concentration of reactive groups are also important factor for controlling kinetics, along with the type of deblocking agent, use of deblocking agent, for example, polyols and amines. And the polyols amines are an important factor because in polyurethane formulation and application, these two ingredients also can be used in the final formulation as a component. So this is a busy slide, but when you look at the slide, so here what we have done is we basically prepared PPG-based pre-polymer, functionalized with the 4 different isocyanates, so MDI, TDI, HDI, IPDI, and then those prepared pre-polymers are blocked with NX 2026 in this case. And then we measured the blocking temperature using DSC analysis method. So here, without anything else, we measured the deblocking temperature of the pure system, and you can see typical deblocking temperatures are pretty high. 120 being lowest, but it can require 186 degrees to deblock. So therefore, there's a clear need to reduce this type of reduce deblocking temperature. Once again, one of the quickest way to reduce the deblocking temperature is using the catalyst. So in this case, we use the potassium octanoate catalyst and then triethylene diamine catalyst in the polar solvent. You can see there's a significant reduction in deblocking temperature. So what we have observed is that when we compare metal catalyst versus amine-based catalysts, metal catalysts tend to provide a better reduction in the deblocking temperature, especially with the polar solvent like glycols. If you have it earlier, I mentioned that polarity of solvent also influenced that. So when you have a polar solvent, you can further reduce the deblocking temperature. And now one other way we talked about is using the polyol as a deblocking agent. So here in this case, once again, same system from the previous, and then we simply add polyol, theoretical amount of polyols. And in here, we use a propoxylated sorbitol as a polyol. As you can see, when you compare from this the first data to this one, by simply adding polyol, you can already see the reduction, sizable reduction in deblocking temperature. And now, polyols, OH groups act as a nucleophile and attack the metastable phenoxy polyurethane bond. That's the key mechanism to lower the deblocking temperature when you use the polyols. And now this polyol also can be blend with the catalyst. So next study is the polyol, and then we add once again 0.8% of catalyst. And as you can see, there is the further reduction in the deblocking temperature here. So not all. Some of system does not have sizable reduction in deblocking temperature, but in general, you can experience, and by selecting the right catalyst, right polarity of the system, and then those you can achieve the reasonable deblocking temperature of your systems. So amine, once again, amine can be used as a deblocking agent, and this is a powerful one. So once again, same type of prepolymer with the different isocyanate and blocked with the NX2026, and then we blend them with amine, and the amount of amine will be based on the equivalent weight of your system. Here, once again, just to repeat, without anything else, deblocking temperature is very high. Now, as soon as we introduce amine in those systems, there is significant reduction in the deblocking temperature, especially with MDI and TDI. You can see deblocking temperature being 1 degree C with the IPDA as a deblocking agent. So basically, amines are much more effective deblocking agent because of their high nucleophilicity in comparison to polyol. And we also noticed that low molecular weight type of amines are more effective effective solution to lower the deblocking temperature. But however, you still need to keep in mind that when your system has a deblocking temperature close to the room temperature or below room temperature, you have to think about the storage condition of your system, because it has to be probably freeze to not to induce the deblocking. So one of the applications of the blocked isocyanate is in the 2K epoxy system. So in this case, that you can see, prepolymer blocked with the NX2026 is blended with the epoxy side. So this will, since isocyanate is blocked, this whole system will be stable. And now when you blend this one with the amine, what will happen, so there will be the actual reaction. What will happen is that, as you know, typically amine and epoxy reactions are quite fast with a relatively high exotherm. So those exotherm will be helpful to initiate the blocking of the cathanol. And at the same time, having the amine, earlier we talked about amine being very effective deblocking agent, therefore lower the deblocking temperature. So in this whole system, you have exotherm and amine, and they will assure that the deblocking of the cathanol will happen in this system. So as you can see, deblocked isocyanate will react with amine, especially room temperature condition, therefore forming the chemically bonded system. And then now deblocked cathanol will stay in the system because cathanol is non-volatile, so it may act as a, let's say, plasticizer or diluent and something and another function based on your systems. So those pure systems, so in this case, the control system has a liquid epoxy with a light 2002, and light 2002 is phenylcamine curing agents. Phenylcamine curing agents are known for good low temperature cure, good corrosion resistance. So these are the control, and then we add a 30% of blocked prepolymer, PPG 2000 based prepolymer, and also Carolite on Dio prepared prepolymer. Then we measure the cure speed using dry hard, and dry through at 2 different temperature. So as you can see, if you're comparing cure speed from controls to for other system in general, adding 30%, which is a sizable amount, 30% of this prepolymer did not reduce the cure speed, and actually rather increase, improve the cure speed in some cases, especially with the NX920103 Carolite Dio prepolymer system. So this study also ensured that the when you use this one, 30%, around 30% of this prepolymer in 2K epoxy system, you can still achieve the cure happening at room temperature and then even low temperature like 5 degrees C. So this study is to understand and then prove that, using blocked prepolymer in the 2K epoxy system can help you to achieve the toughening effect in a way. So in this study, we basically compare performance of prepolymer against very well-known tougheners, ATBN or cold shell particle or epoxy functionalized CTBN. So once again, there's a control system, which is liquid epoxy with the high strength phenylcamine curing agents. So there's control data of Lexia and TPIL and TG. And then now we added 30% of these ingredients, partially replacing liquid epoxy. So 70% of liquid epoxy, 30% of this ingredient, and then cured with NX 5, 6, or 7. So what we have seen is when it comes to Lexia, adding this blocked prepolymer and reference all improve the Lexia quite well. And from the data, cold shell particle being the best, followed by some of the prepolymer blocked pre-polymer. And now for TPL strengths, though, when we, at least in this study, blocked pre-polymer has shown better performance than the toughener. And when it comes to TG comparison, of course, the core shell particle has shown the best TG performance in this regard. However, even blocked pre-polymer, some cases have shown high TG. When you think about the 30% addition of this type of product, you would expect more size of a TG reduction, but the blocked pre-polymer has shown the very good high TG, and I believe this probably has achieved mainly because when blocked polymers are mixed in this system, ultimately they are chemically reacting with the epoxy and amine system. So it does not stay as a non-reactive diluents, they stay as a reactive plasticizer or modifier. That resulted in a higher TG. So we have looked at the NX2026 as a bio-based isocyanate blocking agent for isocyanate and pre-polymer. We have seen so far NX2026 is comparable to phenol, nonylphenol, caprolactam when it comes to the blocking performances. At the same time, using NX2026 can offer you lower viscosity of your block system. And we also noticed that phenols and nonylphenol NX2026 itself, the blocking temperature can be still high based on some of application. Therefore, we have worked on the options to optimize those the blocking temperature. And from study, we have learned that the using catalyst and the blocking agents are a very effective method to reduce and optimize your system. In terms of catalyst, metal catalyst being more effective than amine-based catalyst, and when it comes to blocking agents, amine and polyols are studied, but amine having a high nucleophilicity seems to be much more effective when you're trying to reduce the deblocking temperature. And of course, the blocking agent and catalyst also can be blended together to achieve further reduction in deblocking temperature. So thanks again for your attention and joining this webinar. And you can reach me at ykim@carolight.com, and you can also access to Carolight website from carolight.com. So now we're open for the question.
Thank you so much, In-Mi. Excellent presentation. And reminder to everyone, if you have a question, please feel free to type it in the questions box. I have a couple of questions that people sent to me. One is, what are the key differences between the CNSL polyols and the non-CNSL polyols, vegetable oil-based polyols?
Right. So, our few slides we mentioned this part a little bit. Cashew nut shell liquid. Let me go back to quickly here. Unlike other renewable feedstock, for example, castors, soybean, and those type of vegetable oil-based feedstock, cashew nut shell liquid technology, as you can see from this structure, offers one more component being phenolic, the aromatic structure with a long aliphatic chain. So, most of vegetable oil-based feedstock does offer long aliphatic chain, meaning you will get very good hydrophobicity. However, you do not get this aromatic structure, and aromatic structure typically offers better chemical performances and the thermal performances. And in some cases, in this case, having this group, and then the aliphatic chain also can give you surfactant effect as well. Now, some other key performance we actually have shared here is that when you use a cashew nut shell liquid-based product, we have shown, in fact, better chemical resistance, like alkaline resistance, and better comparability as well. So all those achieved performance, we believe, comes from the structure itself in comparison to other feedstocks.
Excellent. Thank you very much. And one more question. How do you come up with the bio content?
So bio content is typically pretty much only relate to the carbon itself. So you count the number of carbon that originate from the bio. And so basically you can calculate those number based on how the amount do you mix it to make a reaction, and then other side product, and then your real product. But at the same time, there is the ISO and then ASTM method to actually measure bio content. For example, ISO-17025 is the standard method, and when it comes to ASTM, there will be ASTM D6866 will be the actual method to be able to measure your bio content.
Excellent. Thank you very much for an excellent presentation. And I want to remind everyone that the recording of this webinar will be available on the TRFA website in the future. Thank you for your participation, and thank you, Yeonmi, for an excellent presentation.
Thank you, Rick.